Hey, Math 107. We're going to expand on what we looked at yesterday. Yesterday, we were exploring the standard normal curve. This is how data is very often distributed. It's distributed in a bell curve shape, where a large proportion of the sample or the population is close to the average. And then as you get further away from the average, you have fewer and fewer people. Yesterday we focused on, I used the made up statistics that people spend an average of 5 hours a day on TikTok. And then we went from there, had a standard deviation of 1.5. We will look at stories again tomorrow and we'll focus on that. But today, all of the standard normal charts that we use, all of the standard normal curves that we use, will have no context, no story. And so I just want to show you basically the whole focus today is how to use this chart. Okay. We'll have lots of a variety of different kinds of problems. You're going to try them, use the solutions a lot, use the notes and this video. So to start with, and these notes, by the way, they're really nice and careful and lots of writing and explanations. They are on Canvas. I will recreate these notes right now on this video, but you can go look at them in a nicer form on Canvas. Writing on this tablet is not the easiest for me, so it'll look okay. So a couple of basic facts before we start. The whole curve represents 100% of the data. So if you had everything shaded, that's 100%, or we could just say 1. Okay, that's decimal form. And then half of the curve, shocker, represents 50% of the data, or 0.5. This will come into play a lot as we are trying to use this chart. And so speaking of the chart, what we have right here, I should retitle this. Yes, it's standard normal distribution, but I would like rather to call it a standard normal body chart. And the reason I'm calling it a body chart is that this picture up on top tells you exactly what it's giving you. It is giving you the body percent. This will come into play later. Sometimes the curves that we're asking for, they're not asking for a body percent. They're asking for something else. So that just means that every single one of these numbers down here, these numbers are called p-values, but I'll often just say percent. They are body percents. So they are measuring that body, not the tail, not the whole curve. So let me show you an example. So the notation for this is going to look like this. You're going to get a problem. You will draw the curve yourself, and it'll say 0 less than or equal to z less than or equal to 1.57 or something like that. I want to work really hard on my vocab. So the way you might say this, the way I think I see it in my book most often, is they'll say something like, what is the probability that a randomly selected person has a z-score between 0 and 1.57? The key there is I'm going to shade between 0 and 1.57. When I see two numbers in this notation, I will shade between those two numbers. Z throws students off. It always has. And so I want to try and simplify it as much as possible. Again, I think the technical way to say it is, what is the probability that a randomly chosen person has a z-score between 0 and 1.57? But the way that it looks is it's this. If I have my chart laid out, I am going to shade from 0 to 1.57. And the question is, what percent is that? And what's really nice about this problem is that is exactly what our chart answers. That picture that I just drew is an exact match to this picture here. So if I look at that picture that I just drew, let me move my chart up. It matches. And so all I have to do is I just have to look up the number 1.57. This chart is telling me the percent from 0 to the number that I look up. And so if I look up 1.57, which goes like this, it's 1.57. So it's here. The percent is 0.4418, or rather the proportion or decimal, or however I'm supposed to say that. So this is, of course, I immediately forgot. It's 0.4418. Okay, which means the answer to this is 0.4418. And I'm done. That's it. If every problem was like that, this would be the easiest assignment you've ever done. You literally just look up a number on the chart, write it down. But many of the things that we will shade, many of the numbers we'll look up, won't be so simple. They won't match the chart exactly. So, for instance, what if instead of between 0 and 1.57, my setup said, what is the probability that a randomly chosen person has a z-score greater than 1.57? And this just says I should shade everything greater than 1.57. I'm just looking at this symbol. It's telling me to shade to the right. It's literally pointing to the right. Okay. This one I have two symbols. It's everything between 0 and 1.57. When I see two numbers, that's always the way I'll do it. This one has a single symbol and it says greater than. It points to the right. So I'll shade everything greater than 1.57. There's kind of two hurdles to clear here. Number one, what is this saying? Okay, well, that says shade greater than. And the second hurdle is, okay, cool. I've shaded. Now how do I use the chart? So here's 1.57. I'm shading everything greater than. Here's a big hint. No matter what, except for the number 0, because it's kind of built in, but no matter what, when I have a z-score, I will look it up. The question is going to be, what do I do with that number? But I will always look it up. Okay. We just looked up 1.57 on the chart. And so for a z-score of 1.57, I get a p-value of 0.4418. I get a percent of 0.4418. And a mistake that you could make would be to say, oh, okay, well, my answer is 0.4418. But that's not true. The chart does not give me the tail percent. That is not what our chart does. Our chart instead gives us a body percent. It's telling me that in there is 0.4418. Great. So then what's this shaded area? Well, this is where we get a little bit clever. And you guys were doing awesome with this yesterday. We know that from here on, that's 50%. This half right here is 50% of the data. And so if I want to know what this chunk is, then I will take 50% and I'll subtract 0.4418 from it. I'll take 0.5 minus 0.4418. That'll give me the leftover little tail there. That whole thing minus the body gives me the tail. 50% minus the body gives me the tail. Let me extend my page. So then that's literally all I'm going to do is I'm just going to say 0.5 minus 0.4418. And that gives me a final percentage of, what is this? 0.0502. Let's see my own work. Nope, it's 0.0582. I can do. Oh my goodness, 0.0582. So this in here is 0.0582. It's about 6%. It's not very much. That is a lot of what we'll be doing. We'll be adding 0.5 and subtracting 0.5 from the numbers we look up. Okay, I'm looking at the time. I've already been going for 9 minutes. I am going to attempt to get through 3 more examples. I'll go a bit quick, but then you can look back at these nice notes that I have on Canvas to see how I did them again. So let's try this. What if I have the same thing that I had before, only now it's what is the probability that a randomly chosen person has a z-score of less than or equal to 1.57? Oh my goodness. Less than or equal to 1.57. Okay. I want to know what's the probability of that, or really I'm just shading everything less than 1.57. I'm using this as my directions. Okay, fine. So the way that I'll always do this is I like to put a dotted line and a 0 for my middle, a dotted line because I'm telling myself, hey, I may or may not use that in my calculations. Here's 1.57. I'm using a solid line because that is part of it. I'm going to shade everything less than, everything to the left of that. That doesn't stop here at 0. I'm putting a dotted line there to tell myself, unless the problem explicitly says stop at 0, I don't stop at 0. If it said between 0 and 1.57, fine, then I would stop at 0. But that's not what this problem says. It says everything less than 1.57. So what's that going to be? Well, I've already looked up 1.57. That's 0.4418. That is the body percent. That's this chunk right here. That's 0.4418. Well, then what's the rest of this? Well, that is going to be half, 0.5. And so if I want to get the full percent of this entire thing, I'll do 0.5 plus 0.4418. And so I have about 94%. See, our chart wasn't built for anything but body percents, but the standard normal curve is pretty straightforward. And so you can just use it and manipulate it by adding, subtracting. And so, yeah, that one would be about 94%. And I always like to look at that answer. Does that seem reasonable? Could everything less than 1.57 be 94% of the data? Sure. If I had subtracted and gotten just 5%, I would say, no, that does not seem reasonable. That's way more than 5%. Okay, let's try one that to look up two things. So we're going to go back to one where it says, what's the probability that a randomly chosen person has a z-score between negative 2.02. Now I've got a negative. That's interesting. And we'll go right back to 1.57 because why not reuse the same number over and over again? So again, we're between negative 2.02 and 1.57. Should be easy enough to shade. I'm going to put a dotted line at the middle and put 0. We have negative 2.02. By the way, I'm just putting that line at an arbitrary spot. This is just a sketch. It's just to help me get my head wrapped around what's going on. And I want to know what this percent is, which to me seems like it's going to be quite a lot. It's going to be something between, I mean, 2 standard deviations away is 95%, so I'm guessing 90-ish%. It's going to be a lot, okay? Well, to do that, to find that shaded area, what I really need to do is add this to this. What I will do is I will look up both numbers in the chart. I already know I looked up 1.57, that's 0.4418. Now I'm going to look up 2.02. The chart shows that we have a positive body percent. It's the positive side, but the standard normal curve is symmetrical. So you can use it either side. So there are no negative numbers on here, but that's okay. I'm just going to look up 2.02, which here's 2.0. Let's use blue for this. Here's 2.0. Here's 0.02. 2.02 would be right here. So 0.4783 for 2.02. And so I'll go back to my picture. This right here is 0.4783. And so if I want to know this entire thing, all I have to do is add those together. 0.4783 plus 0.4418. And that's going to be a grand total of 0.9201. There's my 90-something%. Okay, I have one more fabulous example to show you, but there's only 30 seconds left that I can record my video. So I'm not going to show, well, I'll do this. You can look at my notes later. I'll just show you that here's an example that was between two numbers that I also had to look up both those numbers. But because they were on the same side, instead of adding those numbers together, I subtracted them. That could use